Hello dear student, myself Vikash Kumar. Today I am going to teach chemical equilibrium chapter. So watch my video carefully. In this video we will discuss about what is active mass, how many type of chemical reactions, reversible reaction and irreversible reactions, homogeneous and heterogeneous chemical reactions. After that we can find active mass. We will discuss about active mass, formula of active mass. Initially we will discuss about first type of chemical reactions. So there are two types of chemical reactions. There are two types of reactions. First is irreversible reaction. Irreversible reaction is denoted by this arrow. Reaction by the heating of 2 mole of KClO3 solid. After heating 2 mole of KCl solid and 3 mole of O2 gas, these products are formed. So this is thermal decomposition reaction, but this reaction comes under irreversible reaction because this reaction is only one direction. So here this is also direction of reaction. After that we will discuss about reversible reaction. Reversible reactions. Now reversible reaction is denoted by this arrow. Here this arrow show forward reaction, this arrow show backward reaction. So in this case rate of forward reaction is equal to rate of backward reaction in case of reversible reaction. So now for example of reversible reaction, by the heating of calcium carbonate solid CaCO3 solid, after heating calcium oxide solid and CO2 gas, these two products are formed. Then after that in case of magnesium oxide, thermal decomposition of magnesium. Now we can write this one. Now other example, by the heating of magnesium carbonate we can observe magnesium oxide solid and CO2 gas. These two products are formed. So you can take a screenshot. This reaction is irreversible reaction because direction of reaction is in forward direction, but in case of irreversible reaction both reaction is completed, forward direction, backward direction. So these two example of chemical reactions, reversible reaction and irreversible reaction. Now we will discuss about chemical equilibrium. Chemical equilibrium is dynamic, so we can say chemical equilibrium is dynamic equilibrium. Finally, we can write chemical equilibrium is dynamic or dynamic equilibrium. Now for a chemical reaction, for a reversible chemical reaction, we can observe, suppose reactant A react with reactant B, then product C and D is formed. Due to presence of this symbol, this is forward reaction, this is backward reaction. So for case of forward reaction, A plus B is reactants. In case of backward reaction, C react with D, A and B form. So in case of forward reaction, AB reactant. In case of backward reaction, C and D reactants. Now from rate law we can write rate of reaction is directly proportional to multiple of power of concentration of reactants. Now for forward reaction, for forward reaction. Now for backward reaction, rate of reaction is directly proportional to power of concentration or multiple of power of concentration of reactants. For backward reaction, now from rate law of active mass for reversible reaction. Now rate of reaction is directly proportional to active mass of reactants or multiple of active mass of reactant for forward reaction. Now, rate of reaction is directly proportional to active mass of reactants or multiple of active mass of reactants for backward reaction. So we can write rate of forward reaction is equal to constant for forward into active mass of A into active mass of B. This is equation 1. Rate of backward reaction is equal to constant for backward reaction active into active mass of C into active mass of D. This is equation number 2. Now we can write from equation 1 and 2 for dynamic equilibrium. Chemical reaction is dynamic, so for in case of dynamic equilibrium we can write for dynamic equilibrium. We can write here rate of forward reaction is equal to rate of backward reaction. Now from equation 1 and 2, now put value of RF and RB, rate of forward and rate of backward. Constant for forward into active mass of A into active mass of B is equal to constant of backward into active mass of C to active mass of D. Now the formula is KF by KB equal to active mass of C into active mass of D divided by active mass of A into active mass of D. So now formula is ready. So we can write constant for equilibrium or equilibrium constant. Equilibrium constant. The formula is Kf by Kd. Okay. So you can take a screenshot. Now I am talking about what is active mass. So what is active mass? Active mass is indicated by small a. So formula is active mass is equal to concentration into a small f. So this is concentration in mole per liter multiplied by activity of coefficient unit of A. C into F. If F is equal to 1, then A is equal to C into 1. So A is equal to C. Finally, once again, we can write unit of concentration is mole per liter. So finally formula is A is equal to C is equal to N by V, number of moles of molecule divided by volume in liter, number of gram molecules and divided by volume in liter divided by volume in liter. So unit is mole per liter. You can take a screenshot. Now we will discuss about graph between time and concentration. Now for dynamic equilibrium of a reversible reaction. Suppose R is reactant and P is product. Now P is reactant, R is product. For forward reaction, R is reactant, P is product. For backward reaction, P is reactant, R is product. Now we can draw graph between concentration of reactant or product versus time. We can observe here a beautiful graph. At vertical we can observe concentration, okay, in mole per liter, and at horizontal we can observe time in second. Now for product we can observe here, with increase in time concentration of product become increase, okay, time is here, concentration is here, then with the increasement of time concentration become increase. For reactants, okay, now for reactant we can observe with the increasement of time concentration become decrease. So this is the graph between concentration of reactant or product versus time. So you can observe. Now we will discuss about equilibrium. This is equilibrium point. Now again you can take a screenshot. Now I am talking about physical states of reversible chemical reactions on the basis of physical states of reactants and product. In case of reversible reaction, there are two types of reversible reaction. One is homogeneous reversible chemical reaction and another is heterogeneous reversible chemical reaction. In case of homogeneous reversible chemical reactions, physical states of reactants and products are similar. But in case of heterogeneous reversible chemical reaction, physical states of reactants and products are not completely similar. So you can observe by these examples and definitions. Watch my video carefully. Now, on the basis of physical states of reactants and products, there are two types of chemical reactions. First is homogeneous reversible chemical reaction. According to homogeneous reversible chemical reactions, those reversible chemical reactions in which physical states of reactants and products are similar. Now with the help of example we can easily understand. Example number 1, whenever H2 gas react with N2 gas in this reversible reaction, we can observe product ammonia gas is prepared. Now after balancing this equation, we can observe two reactants, both are in gaseous state and product is also in gaseous state. So this reaction comes under homogeneous reversible chemical reaction. Now another example is whenever sulfur dioxide gas react with 1 mole of O2 gas, then sulfur trioxide gas is formed. So this reaction is also comes under homogeneous reversible chemical reaction. And after that we can observe another example. Suppose H2 gas react with I2 in gaseous state. After reversible reaction, 2 mole of hydrogen iodide gas prepare. So these are the example of homogeneous reversible reaction, because all reactants are in gaseous state and products are also in gaseous state. So if physical states of reactants is completely similar with physical states of product, so these reactions are comes under homogeneous reversible reaction. So you can take a screenshot. After that we will discuss about heterogeneous. Now second is heterogeneous. Second is heterogeneous reversible reaction. Okay, those chemical reactions in which physical states of reactants and products are not completely similar. These reactions are called heterogeneous reversible reaction. As for example, we can easily understand with the help of suitable example. Suppose CaCO3 is solid, and after heating, after thermal decomposition, calcium oxide solid and CO2 gas we can observe. By the heating of magnesium carbonate solid, after heating magnesium oxide solid and CO2 gas is prepared. Now with the help of this suitable example, we can observe easily physical state of reactants. Observe in solid state, but product solid with gas. So they are not completely similar due to different physical states in reactants and product side. Due to the dissimilarity of physical states of reactant and product side, we can say these reactions are very good example. These reversible reactions are very good example of heterogeneous reversible reaction. So you can take a screenshot. Now this question is based on calculation of equilibrium constant K. So watch my video carefully. Now according to this question, the rate constant of forward reaction, backward reaction of reversible reaction are 10 to the power minus 4 and 10 to the power minus 6 respectively. Calculate the equilibrium constant. So equilibrium constant is K. Now according to question, given that we can observe here from question, constant of forward reaction is denoted by Kf, and value of Kf is 10 to the power minus 4 and value of Kb is 10 to the power minus 6. Now from formula we can observe here equilibrium constant is formula rate constant of forward reaction divided by rate constant of backward reaction. Now after putting these values, 10 to the power minus 4 divided by 10 to the power minus 6, 1 by 10 to the power minus 2, so 10 to the power 2, 10 square, so 100 is answer. You can take a screenshot. Question is complete right now. Now this question is completely based on calculation of equilibrium constant K. According to this question, the rate constant of forward reaction and backward reaction of reversible reaction is 10 to the power minus 2, 10 to the power minus 4 respectively. Calculate equilibrium constant K. Okay. According to question, given that rate constant of forward reaction Kf is 10 to the power minus 2 and rate constant for backward reaction 10 to the power minus 4. Now from formula equilibrium constant K, here equilibrium constant is rate constant of forward by rate constant of backward reaction. Now after calculation we can observe 10 to the power minus 2 divided by 10 to the power minus 4, 10 to the power minus 2 is equal to 100. So 100 is correct answer. So you can take a screenshot.